Well, hello everyone. Welcome to another edition of OTel in Practice. And today we've got Hanson and Eliab from Embrace. They're going to take us through some of the challenges and some of the opportunities as well of doing a data model and API design in mobile apps. So in OpenTelemetry, we talk a lot about backend, but we'll see how we can apply OpenTelemetry to the client side as well. So we will do a presentation first, and then there will be time for Q&A, and drop in a link in the chat. And then I've created a agile coffee board. You can go there, you can add your questions, and then at the end of the talk, we'll go through the Q&A. You can vote for your questions as well. So feel free to add your questions as you see in the presentation, and then we'll go through them at the end. So without further ado, I'll introduce Hanson. I think you're going to be picking off. So take it away.
Great. I'm actually going to pass it off to Eliab to kick it off.
Nice. Hi, everyone. Yeah, like it was mentioned, my name is Eliab Sisay. I am a product manager at Embrace. You can go next slide, Hanson. We are a mobile observability company. We provide developers with SDKs that they can integrate into their mobile apps to monitor performance in real time. And our main goal really is to help developers keep their apps running smoothly by proactively identifying and resolving issues, really with the objective of improving the overall user experience. We're also heavily invested in OpenTelemetry. We began that transition about 9 months ago, and it's really helped us provide our customers with a more unified and comprehensive view of app performance from what's happening client side on the user's mobile device all the way to the backend services that power those experiences. And in doing that migration, we discovered that while the benefits of OpenTelemetry are numerous, there are some specific challenges that occur when trying to implement it in a mobile environment. And that's kind of what we're here to talk about today. And I'll be honest and say that the term "we" is very generous. Also on the call is Hanson, who we talked about. He's an Android architect at Embrace, formerly a mobile performance engineer at Twitter. So I'm just here to do kind of a brief intro, and then I'll hand it off to Hanson, who will be doing a majority of the presentation. Next slide, thank you. One more. So I want to start by just setting a little bit of context. So in 2022, the average mobile user spent a little over 4 hours a day on their phone. And of that, over 90% of it, or about 90% of it, was within native mobile apps. And by the end of this year, mobile apps are expected to generate over $900 billion in revenue. And if you yourself think about your own mobile use, I'm willing to bet that the brand or companies that you interact with most have a native app that you use consistently. Now, as we think about the observability ecosystem, we've spent the last 5 to 10 years really trying to figure out how we do observability better for backend systems. And there are a variety of standards that were created, most notably OpenCensus and OpenTracing, which form the foundation for where we are today with OpenTelemetry, to provide the visibility into the health of distributed systems. But mobile apps are not a distributed system. They are installed software running on distributed compute resources that interact with distributed systems. And there's a lot of unique challenges with that environment. Take session tracking, for instance. In the mobile world, a user session can be anything from several seconds to several hours, and it can be interrupted by calls or network changes or the app running in the background, which is really quite different from what you see server side. Mobile apps themselves are also extremely different. Like a gaming app, for example, needs to track things like frame rate and rendering times, while a financial app might focus more on transaction speeds and security events. Add to that the fragmentation in the mobile ecosystem, where you've got multiple operating systems and countless device manufacturers, and it's really easy to see how complex that becomes. We were looking at the number of unique devices for just one customer, and we saw that there was like 42,000 plus different combinations of device models and chipsets that could potentially exist, which is, crazy. And for most of its life cycle, like observability and monitoring in the mobile ecosystem has been mostly proprietary systems designed by vendors. Like the typical starting point is Firebase Crashlytics, which is free but highly sampled and extremely limited in its feature set. So if you're a serious app developer, you're not going to use that. And that's led to a bunch of vendors building their own proprietary standards and trying to convince people that they should be serious about observability with their solution. But mostly it's just crash reporting and error tracking. And so the result is that the paradigm looks something like this. And the unfortunate thing is that a lot of mobile engineers actually consider that to be kind of acceptable. But when we talk to customers who truly care about the user experience that their customers are having on their mobile devices, they tell us that all of their customer impacting SLOs are directly tied to the mobile device, but they don't have a good source of information that correlates that data to the work they're doing to build reliability and resiliency in their backend systems. And so that's what Hanson's going to be talking about, which is some of the challenges in this paradigm that we're facing today, and some of the opportunities and how we're working to address that. But more than anything, I think today is really a call to action for the people in the Zoom, for the people watching. If you yourself, or if you have coworkers or people that are interested in the mobile ecosystem, we would love for you guys to get involved. Hanson's involved in the Android SIG and the client-side SIG. We have people working in the Swift SIG. We're working on OTel contributions for React Native and Flutter. And we're really committed to making mobile observability as robust and standardized as it is for backend systems. And we'd love to involve as many of you in that effort as possible. So with that, I'll hand it off to Hanson.
Thanks, Eliab. So I am here to talk about how mobile is different in terms of observability. I think the first thing to approach this is that the crux of the problem is not actually about simply moving tooling onto these mobile platforms and making them run, because there are fundamental differences that are embedded in the assumptions that we make when we have observability and the questions that we ask of our tooling. And without first identifying and acknowledging these differences, we can't start improving the specs or tooling, because we don't know what it should look like. To make the front of the horse look like the back of the horse, we got to first figure out what the face should be. And here is what I'm trying to do is just to go over a little bit what the differences may be. I can spend a couple hours here talking about this, but hey, we don't have that much time. So I'm just going to concentrate this in three general areas where mobile is different. First is the runtime environment. We're talking about dynamic, heterogeneous runtime environments running devices that are unpredictable, 42,000 unique chipsets and device combinations. Not only that, the environment that they run in is extremely dynamic as well. You walk into an elevator and you lose your mobile connection, you lose your network connection. You background the app to answer a notification. That affects how the operating system runs the app. Not only that, the actual hardware that is running your app is quite severely limited. Phones exist 10 years ago, still in use today. Phones are released last year that cost $99. And well, the hardware mirrors that cost. And the OS not only limits what you could do with that already limited hardware, it also does it in a very unpredictable way. So what you have is a dynamic environment where you don't know what is actually executing your app. And not only that, objective performance, which is typically what we measure, is only part of the equation, because what makes an app slow differs in terms of where I'm using it or whether somebody else is using it. Perceived performance is also part of the equation, and SLOs have to somehow take that into account. Another aspect of mobile that makes it challenging and different than backend is the fragility of the capture and transmission pipeline. How to get data from these devices onto servers. I can do something with it. Data can be lost in multiple stages before it gets captured because it was a crash, before we persist the data, or after we persist the data because the network connection is unstable and we can't get the data over to the server. And even when the server gets the data, it could be delayed or out of order. So what you get may not be the full picture until several hours later when more data comes in. Thank you, network connections. And lastly, the data that we capture has to center the user experience, because operational runtime and device state is useful only in how they provide insight into individual user experiences. end to end. Otherwise, it's just trivia. On mobile, we're observing millions of independent app instances, but each one of the measurements we get maps back to user. It is not merely a state of health of the system. If something is slow, somebody is looking at a very slow phone. You think of P99, what does that mean? Well, P99 is 1% of all measurements are that slow or slower. So if you think that's an outlier, well, 1% of interactions being that slow means it is more than an outlier. It is something that we have to capture. Now let's talk about OTel. So in general, OTel works really well as a lingua franca of observability. Its backend roots, though, mean that it was designed to solve a problem with a very specific context. And when we change that context to mobile, some parts starts to not fit very well. And these are the ones that I'm going to talk about. So first, let's talk about spans. Spans are great on OTel if you want to measure the duration of operations of applications that have a very fixed runtime environment, predictable runtime code path. So you can actually measure and calculate deviations based on some baselines. They are not so great if, say, duration is not an indicator of performance. If you want to measure a period of time, well, OTel signal to use, it looks like it spans, but is it? Because duration is not an indicator of performance, and you start aggregating and say, hey, what's P95? That starts to not make sense. Also, operations run for a long time. In OTel, well, unfortunately, you don't get to know what happened until it ends, either in a failure or a success. But what if it gets interrupted in the middle through a crash that we don't know about? Mobile apps could be killed without actually alerting the app. So operations like that are gone or lost. And with OTel itself, we wouldn't know about it because it's not done. And that's kind of challenging for mobile. Also, operations that need to be contextualized with a lot of mutable state that are expensive to obtain, well, that's a challenge because in OTel, you write the data into the spans, the span events or attributes. But sometimes the act of getting these types of state takes a while for the mobile app to actually get from the OS. And for us to basically block the ending of a trace just to write an attribute, that's not fantastic. The second point I want to talk about is that the protocols and APIs of OTel make certain assumptions that are just not true on mobile. Now, for example, assumption one is that telemetry is recorded and transmitted reliably. And you could trust that data that gets recorded will make it to the server, the collector in a reasonable amount of time. But as we mentioned before, that is not true in mobile. And it could also not be true in a number of fascinating ways. So tooling that is usable on mobile has to take that into account and build in resilience, like disk persistence, for instance, before export. Thanks to Sisay for doing that on OpenTelemetry Java, or sorry, the OpenTelemetry Android extension. It's extremely helpful in production. In the future, perhaps be nice for ways for us to atomically transmit a group of related telemetry so that we don't get into this, weird state in the back end, wondering if more data is coming. That'd be nice. Another assumption is that recording and transmitting telemetry doesn't put a strain on system resources. The SDK are well written and they perform well. So on the back end, use them, it's no problem. However, on low-end devices and metered networks, it means that every signal captured potentially reduces performance or costs users money. So we have to be a lot more careful in how we record data and how we transmit data. And even simply the act of getting the data to record can be expensive. So the consideration that we have to go into what to record is, I think, a lot greater, and depends on the use case. Another assumption is that engineers that use the API understand low-level concepts like threads or context propagation. Even the idea of tracing and what spans are may not be universally understood if you change the audience to mobile engineers, simply because the variety of background of folks building mobile apps changes quite a bit. It could be somebody who's just done a 6-month boot camp who is building, a mobile app for the local grocery store. And they want observability too. They want to know why their stuff is slow. But they're used to higher level constructs like coroutines when you're using threads, but not really. They don't know about it. And how do you explain propagation when they don't understand the existence of a thread? So adapting the APIs to be idiomatic is one thing, but making those concepts understandable by those without CS backgrounds, that's another challenge right there. And lastly, another assumption is that traced operations have a clear execution boundary and code ownership. So you have a service that creates a span in the runtime. Generally a team owns that, front to back, and you transmit the context via context propagation, et cetera, as you would in distributed tracing. Unfortunately, things are not as clean on mobile because a single span for an operation can go through several modules owned by several teams, and not all of them may be aware of all these problems. So instrumentation can be extremely brittle if you don't have the right infrastructure in place to catch, regressions where implementation changes, but the instrumentation doesn't. It's not as modular or nicely connected, cleanly connected as you would for a distributed trace, just because of how mobile apps are architected. And the last OTel thing I'm going to talk about is that mobile devices are millions of independent instances. And OTel generally assumes that the system being monitored and observed is one connected system. It could be made of dozens of microservices deployed in various ways, but effectively they all roll up. And metrics in that context makes a lot of sense, OTel metrics. But for mobile, when we have disconnected app instances running, that starts to break down because metrics need to be grounded in the context of the system that emits them in order for the baselines to be created and compared. And munging together metrics from phones of various models into one limits how useful those generated metrics are. What does P95 of heap size of an app at 1 minute mean when you look at the entire fleet of devices? Well, I don't know. When it changes, when it increases or decreases, is that good or bad? Well, I don't know, because we don't know the reasons, because these are different systems. And not that metrics aren't useful on mobile, they're extremely useful, but you tend to need to have like-to-like comparison, apples to apples, and it tends to involve dimensions that are high in cardinality. And unfortunately, that just doesn't work fantastically well with OTel metrics. And also just simply the strict time-aligned aggregation is not really suitable for apps that have operations that have a variable duration and have data come in at any time. It just wasn't meant to do what mobile wants it to do. But that's okay, because these are not insurmountable challenges. These are ongoing things that we could work with the protocol and the SIGs and the folks to kind of improve. So we're working with with the various SIGs to try to get some of these problems surfaced and addressed. We are also at Embrace having workarounds to go around OTel, or perhaps use OTel in I would say non-standard ways in order to get the data to do what we want it to do. But that's not the end state. The end state we want to see is a diverse ecosystem and tooling that builds on not only what folks in OTel have done before, but also extends to support the plethora of use cases that we're bringing up. And frankly, this is just the beginning, because mobile apps that I'm familiar with run on very small, restricted, set of circumstances, and phones and tablets is what I'm used to using. I haven't worked on cars or TVs, IoT. But those apps deserve observability as well. And I'm sure as we take the tooling and the spec forward, more use cases will come on the board and say, hey, I want to connect my data from my TV to my backend data. Well, what additional challenges are there when I don't even know how a TV works in terms of how it uses Android, but I'm sure it's different, and I'm sure there are new things. And at this point, we're just exploring ourselves. We're trying to ask questions. We're trying to figure out if our assumptions are correct. Are there things we could change about how we used to do things in order to fit more into OTel? But at the end of the day, we want everyone to kind of come up with their use cases and help ask these questions of mobile and client use cases for OTel. Great work is being done in the Android and Swift and client SIGs already, but I think there could be more going forward. And folks listening, maybe they converted, they believe in OTel, but hopefully other people also watch this and say, hey, you know what? I looked at OTel, it didn't really fit, but after this presentation, maybe I can make it fit. Maybe I can use it in a way that is productive and actually truly have this become the lingua franca of observability for both the back end and the front end. So that's enough of us talking. Any questions? I'm going to end the presentation if I can. There we go.
Thank you very much, Hanson. For those that have joined a bit later, maybe haven't seen this message, we've got an Agile coffee board. You can add your questions in there. Then we've got a couple of questions. We'll start with one related to, so we've got in web, Code Web Vitals have become a standard to measure user experience. For better or worse, do you see an emerging standard to measure equivalent concepts in mobile apps for sluggishness or speed?
Yes. So, with OTel, everything is defined effectively as semantic conventions built on the existing signals. And at Embrace, we've kind of modeled some of the telemetry capture for things like ANRs on Android and various other kind of mobile, slowness, sluggishness. We did it in a certain way that, it works. But is it the best? We don't know. But once we figure it out, we'll want to work with the SIGs to submit semantic conventions to model that. And I believe, especially with the introduction of these emerging specs of profiling and even entities, a lot of these problems that we have are going to be addressed. So it's a matter of figuring out what we have and then defining them. And if you're interested in defining certain slowness metrics or metrics telemetry for mobile, let's talk. There's one that's I'm in the middle of putting together with the help of a lot of folks from the client SIG, a crash semantic convention that spans platforms, that's different from exceptions, that we have many more down the pipe and is limited by the bandwidth that we have. But anything that can be, should be standardized as semantic conventions. So it's a very long way of saying yes, and please help.
Good stuff. Let's go on to another one. There are some options available for OTel instrumenting iOS or Android code. What about applications using Kotlin multi-platform? What instrumentation options are available? Any additional considerations when instrumenting KMP?
So Kotlin multi-platform is interesting. I mean, for those unfamiliar, it's similar to React Native or things like that, where you write it once and it kind of generates native apps for the various platforms. I'm sure I'm getting something wrong in the technicality there, but the idea is that you have one code base, multiple platforms. There isn't an SDK that I'm aware of that works in such a way. that is built natively into Kotlin multi-platform that will emit OTel telemetry. Whenever we have iOS or Android, Android we use a Java SDK, at the core, and iOS uses the Swift SDK. To have Kotlin multi-platform, either there has to be a native SDK for Kotlin multi-platform in Kotlin only that will, transpile into the native platforms. So not only iOS and Android, there's, web and a whole bunch of different platforms. Or there has to be a way of getting a bridge built to the other SDKs. We are evaluating, at Embrace at least, we're evaluating how best to approach this. We think the native way is the best way, but we don't know. We're working through some of these problems, not specifically called multi-platform, but with React Native, which is, I think, probably more well known and more well adopted. There's definitely opportunity in Kotlin multi-platform, but first we got to have an SDK before. We got to have a way of getting OTel telemetry working on that platform, or like recording first before anything else can happen. So if you're working on it, you should start talking to people and think about that, because I'd be interested as well.
Thank you. I think the next question is about one of your challenges. Sounds like one of the core challenges for mobile observability is the variability of runtime environments, software and hardware. Is this entirely an open problem, or are there suggestions on how to start tackling this?
So I think to do it natively in OTel, I think entities will have to, for those who may not be familiar with that particular working group, the entities working group is a way of, I guess, capturing external mutable transition of states that's independent from, but related to apps. And I think for us, we could see it capturing a lot of this variable state without having to directly, well, actually the implementation's not yet, so I don't know. Maybe it could work. We have done certain things that we're not super, we've done certain things to work around this that may not be idiomatic. So we're using spans to log, I guess, durations of interesting things happening. And then on the back end, kind of, merging the stuff all together. It's not great, but also it also allows us to capture this stuff independently and not have telemetry reporting be blocked, and also not have to encode every change of network condition onto every piece of telemetry sent, and have race conditions that will, especially on mobile apps, make the edges a bit blurry. So we have something working, but we're not sure if it's the best quite yet. And we're really looking for entities, being able to do that or help us. Does that answer your question? I think there were two parts. I might have only answered one part.
I'm assuming so.
Oh.
I think we've got a few questions, so I'm going to move to the next one. I know that you're part of the client-side instrumentation SIG, so this was quite an interesting one. How closely or not is mobile instrumentation to browser instrumentation? As far as tracking user journeys, for example, is the client-side instrumentation work geared towards one or the other, or are the data models for both browser and mobile considered the same or similar enough?
I think there are differences, but certainly there are a lot more similarities with web apps and mobile apps than I would say between mobile apps and backend distributed traces. So I think the differences are more nuanced, and I think there's enough similarity that anything that we should consider for web, we should consider for mobile, and vice versa. There may be cases where it is immediately this doesn't fit. But honestly, you could run a mobile application on a mobile browser on a mobile device. So all the environmental changes are effectively similar that they have to deal with. So I think in that respect, they are very, very similar. So yeah, we work very closely with the web folks.
Cool. Moving on. what different types of mobile apps require different kinds of data models. For example, an online gaming like Magic the Gathering versus a social media app like Instagram or a messaging app.
Oh, sorry, the question is, does it or?
Yeah, do they require different kinds of data models, those different types of apps?
Certainly different semantic conventions, I would say. And also there are certain characteristics about the runtime that is more interesting to high frame rate apps like games, for instance. If you're using I don't know, Salesforce online, frame rate, like scroll jank is bad, but it doesn't deter from the experience that much. And also it's not as sensitive to, say, mobile device capabilities. But if you're running a Unity game and your frame rate drops by half in critical instances, you want to know about it. So having more detailed data for that kind of stuff will be applicable to certain domains and not others. But I think that becomes more of a challenge of tooling and instrumentation rather than the spec. I think the spec as it is, with logs and spans, well, events actually specifically, I think, and spans, and hopefully a way of classifying spans in the future. They give us enough of the building blocks to model these different use cases. So the same challenges that we have in terms of transmission, things like that, as long as those are dealt with, I think a good portion of that stuff is going to be taken care of. Now, there may be additional things that I'm not aware of that will certainly need to have different types of consideration. But I think before we run, let's just crawl. And I think getting Unity and others, those different apps that we may not typically think about, console apps, for instance, you have McDonald's and you have that thing that opens for 24 hours. That's a different use case than a mobile app that you background all the time after seconds. I think with the work that we're doing now, hopefully we'll move things forward enough so that we can start looking at some of these more challenging issues like frame rates on Unity and things like that.
Cool. I think this next one relates back to some of the earlier questions, but you mentioned that duration is not an indicator of performance. Are there golden signals for mobile, irrespective of device type and OS version, or do we always need to take these factors into consideration?
I think the golden signal is whether the user is happy or not. And on mobile, there are indicators of whether a user is happy in terms of whether they actually come back and use the app again. So things like simply DAU, whether the user comes back, a usage rate, because just because one operation is slow, the effects could be multiplied. If you have many instances of these slow operations, you basically get fed up with the app. So, at the very end, the very highest level, whether the app is being used is a good indicator. But going lower level, because that level is almost too late sometimes, whether an operation succeeded. Users tend to give up on operations if things take too slow to load. They background the app, or they hop to another page or whatever it is. So looking at abandon rate of operations is useful if you're tracking whether a particular operation is taking too long. So looking at duration in those cases, even if duration is important, abandon rate is actually super important as well, because you can actually have a case where your P50, P95 goes down because more people give up. So your success rate reduces, and your performance increases. And you're like, well, what's that? Well, it's because it's so slow, people are giving up. So the population is different underneath. You're losing people already. So all the people that are remaining are the fast people. And in fact, this is actually a key problem in mobile performance, is that people look at the current state and you're like, oh yeah, P99, it looks great. Well, you haven't considered people for whom your app is way too slow and you can't even use it, or they use it, they install it, it's too slow, they uninstall it. So you naturally filter out a whole bunch of users that would otherwise want to use your app, but it's just too darn slow. So this kind of self-fulfilling prophecy of, oh, I don't have to invest in apps because people experience them high quality, fast. Well, it's because you've lost all the people, and the inability to track those you've lost is a huge, I think, miss in mobile observability. And I think OTel, we have facilities to track it. We can't end the span, with unsuccessful ending. So data can be collected to take care of this use case. And I think that, to me, is the most important thing to track. Is not just duration, it's whether or not it actually succeeded.
Can I add just one other thing there, just from my product hat here? I think the golden signals that are asked in that question really depend on the type of app that you have. So Hanson talked about startup and abandon rate and slow frame rates. All of those can have different impacts on your users depending on the intent of your app, whether it's, like we talked about this earlier, whether it's a gaming app or a financial services app, or whatever that may be. So if I were PM or working on a mobile app, you should really go back to what are the primary key workflows that we need our users to do to make this a successful transaction, and I use that term very broadly, for them. And then you go instrument those based on whatever that is. So, for a gaming app, your golden signal may be frame rate, because if your frame rate is as high as possible, and your users are having a really frictionless experience, you see gameplay time increase, you see all these other second order effects really turn into really have positive impacts on those second order effects. Whereas retail app, it's really about checkout, right? Like, how fast is that checkout flow for me? Are the operations that belay our checkout flow, are they performant? Are they reliable, et cetera? So it really, really depends on what your app is trying to do.
And also the audience is important too. Like, are they using your app because they have to? Or are they using your app because they choose to? If you're a game and you're slow, well, I can just play another game. If your workplace uses Microsoft, no, I shouldn't say, uses certain apps that you have no choice but to use, you know what? It's a little slow, but you don't have a choice. So the golden signal there may be a little bit less than if folks have more options to go.
Next question. I think this is specific type of app as well. Do you know of some use cases of OTel working on video streaming apps like Netflix?
Not that I'm aware of. And if they exist, it would be, I think, the instrumentation would be fairly bespoke, because, no, not that I'm aware of, but it would be very interesting use case.
I think we've got two more. Resource utilization, like CPU or memory, is normally represented as a gauge in a time metric, time series format on a backend system. Do time series make sense in mobile apps at all?
Certain time series, I would say utilization less so, because the app is not the only utilizer of resources. And you could be running very, expectedly, and something at higher priority, the OS decides to schedule. Somebody, starts a video in the corner of their tablet. They have multi-screen enabled, and suddenly the fast cores are now going to the mobile tablet video. And well, your app is running, and suddenly things are slow. Suddenly you are getting issues or you didn't get before. It's good to track the utilization of the CPU, but there are probably other things you would want to know about, like that the utilization is supposed to tell you. So I think the key is can the utilization tell you information that you can't get otherwise? And I think on mobile, there are just so many different things that could affect utilization that you almost need to capture so much other contextual information for that to be useful, that if you're going to do that, you may as well go direct and say, hey, are we seeing lag? Are we seeing failures? Are we seeing unexpected occurrences in the app in certain instances, and knowing that your app is not being prioritized, that's important. But how big of the heap is, for instance, the OS changes that on you so much, it'll GC out of in the most inappropriate places, simply because it wants more resources for other apps. It'll kill your app in the background because another app is running and really needs it. And it's no fault of yours that your thing got killed faster. It's something else that affects it. So resource utilization, there may be use cases where it's useful, but I think for me, it's harder to use the data.
Makes sense. I think this is the last question we've got. Do you have some idea of when OTel mobile instrumentation might be ready for use in production? Is it months? Is it years?
It's ready now, depends on what you want to do. There is SDKs out there, directly, the Swift SDK and the various JavaScript SDKs. So if you want to kind of roll your own, it works. The Android OpenWG Android project is something just drop it in your app and it'll kind of do some monitoring for you. The Embrace SDKs, you could actually use it without using Embrace. You can just drop it in, configure your exporters to go to your own collectors, use our implementation of the tracing API to have instrumentation libraries write the data to Embrace sessions and have it all sent to your own servers without Embrace being involved. I'm sure there are other implementations out there as well, but it depends on what you want and what you need. There are things off the shelf we can use for free, and you can also roll your own with the SDKs. All the challenges I was talking about really is to build a platform that is encompassing of all the corner cases that we want to support for our, all our customers. If you have a specific app with a specific use case with a specific thing you want to measure, you may not need any of this other stuff. And so also, if you're not sharing that code, if you're just kind of using it on your own, well, who cares about semantic conventions if no one else is going to look at that data? Now you're quite locked in to your own instrumentation, which is not a good thing, but if it works for you, it works for you. So I would go ahead and fork some of these repos and just try it out. They should work. They do work. There are apps that are in production with all of these SDKs. So
cool. I think that's all we had. So thank you very much, Hanson, Eliab. Is there any closing thoughts? Anything you would like to add to finish off?
I just go back to kind of where we started this, and I think as Hanson's been talking about through this at all, is that we really, really, really want to get more people involved who care about mobile in the working groups, in the SIGs. Like, we are opinionated and we come to it with our own experiences and the work that we've done, but we're by no means the final arbiter of what is right and wrong in mobile. And the only way we can work through those is having a variety of use cases. And I think that Netflix question is a good example of one that we don't deal with a lot. And so we may not be close to all the intricacies that come with running a video service at that scale or other services at that scale. And so if you care about mobile, even if you're not working directly on it, or if you have teams that work directly on it, we would love for you guys to get involved in the SIGs and provide your perspective and input.
Yeah, the ecosystem is just emerging. I think for mobile, there isn't enough diversity. There aren't enough kind of folks leveraging the SDKs and build instrumentations for mobile use cases and mobile libraries that are popular. I think the closing thought is that if you're using OTel or if your backend is using OTel and you're not, you could actually get a lot of mileage just by talking the same language and using the same signals. I used to not think there was a ton of overlap in terms of just mobile folks can just have that data, and then backend folks, all you have to do is encode all your conditionals and conditions and your requests, and the backend has all that data, right? Well, it's not so easy to ingest all that crap in a performant way at every request. So I've come around to understanding the utility of having two separate sets of data that can be connected. And I think this is what it does. So if you're a backend person and your company has mobile apps that use unnamed observability companies that may be free or maybe very not free, but that don't really talk to your backend signals, well, have a look at OTel and see what you can get in terms of things that are frankly even better, especially if it's provided by folks who only do mobile. There are a lot of things that are not captured if you just use, folks that, well, anyway, forget it. I'm not gonna, whatever, blah, blah, blah. Yes.
Join us. I guess that's the thing. Join us on the CNCF Slack. I'll post the link in the channel, OTel client-side telemetry. We also have the OTel SIG end user channel if you're an end user and you want to discuss more things about how you're approaching open telemetry. So yeah, thanks again, both Hanson and Eliab, and we'll hopefully see you in the next edition of OTel in Practice. Thank you. Bye-bye.